Hello guys, so this is my biomimicry lecture. So this is our next topic. Let's see how it goes. This is my first attempt at doing a video lecture. Hopefully you guys can hear me. There's an AC unit running right next to me, so hopefully if I talk loud enough, we should be able to actually uh, go through this and achieve it. Let's see how it goes. So what's biomimicry? So the actual definition comes from two Greek words, one being bios, which means life, and the other one mimesis, which means imitation. So in other words, biomimicry is basically a, a way or a process to imitate life. So we can break this into three main components. So we can view nature as a model. So we can use nature as a way to actually be able to solve problems. We can use also nature as a measure. Basically, we can use biomimicry as a standard that will tell us or will judge us how sustainable or how righteous we're being about our processes. And the last one, basically, we can view nature as a mentor. So as a way in which we can actually view life by imitating life, basically. And also, it's, by the way, if you recall from the beginning of the school year, biomimicry is one of the values of biodiversity. Now, the concept is fairly new, just a few years old, but it's actually picking up speed since we're trying to achieve a more sustainable existence. And therefore, many of the answers that we have when it comes to answering problems is actually found in nature. So, kind of a good example here. So, for example, how do plants or how do leaves on a plant or petals on a flower actually stay clean? Basically, when it rains, water doesn't stick to the surfaces of the plant, of the leaves and the flowers, because the surface is hydrophobic, meaning that it basically rejects water. So water doesn't stick to it; it just glides down. So we would be able, for example, to use this model and apply, let's say, to a wall or a surface. The surface technically will be pretty much self-cleaning. We just need to spray water, and then the water will just glide down carrying the dirt, instead of having to use caustic chemicals or chlorine or anything like that. We'll just basically sprinkle some water and the surface will clean up. Quite simple. Obviously, there's more profound uses for this process, but I would say it's actually not that bad if we can actually avoid from using nasty chemicals to clean a surface. A more profound example would be this one here on this side of the screen, which is actually my right. There's a photo of a termite mound. This termite mound basically is from a species of termites that live in Africa, Zimbabwe, to be more, I guess, to be more exact. So obviously, it's really hot during the summer in countries like this one in Africa. So people may wonder, so what happened to the termites? And the termites live inside the mound. And by the way, these mounds are basically buildings. They're up to 10 feet tall or so. And of course, it has all sorts of tunnels and openings throughout that the termites actually walk in through there. So it's almost like a maze in a building, a lot of hallways per se. So it makes you wonder how these termites do not cook in there in the middle of the summer, and that's because they leave some openings within the structure or that actually allow for air to flow, something known as passive cooling through a temperature differential or convection. Air will flow, trying to push the hot air out. Cool air flows of the draft that is caused as this hot air is being pushed out. It's basically the ventilation. So they basically have achieved self-sustaining passive AC without the use of a motor or a compressor or anything that actually has to push or forcibly push the air out, which is known as an active AC, basically. So if we would be able to actually apply this into a building, let's say like this building here in Eastport, the Eastport building here in Zimbabwe, actually we would achieve a free passive AC, basically a constant light draft moving the air, preventing it from getting stale, preventing it from actually heating up, without actually the use of electricity, without having to spend on a massive AC system. So this is a way in which nature solved this problem of basically preventing stale air and therefore killing these termites within the mounds. Good example, actually. So basically, we're using nature's guidance when it comes to this. Another one is this one. This is the bird here, the blue bird. That's a kingfisher, found mostly in Africa and Southeast Asia. We do have a species here known as the belted kingfisher, but this pretty one, the iridescent one, is from Southeast Asia, if I'm not wrong. So the backstory is basically that when scientists designed the bullet train in Japan, as the bullet train was actually going through the tunnel, it would start building up pressure, air pressure. So that pressure started to compress against the sides of the tunnel and into the train. So whenever the train exited the tunnel, all this energy would be released, creating this massive sonic boom. Now, no explosion, but it was extremely loud, and every time the train would pass by, it will actually sound like there was some kind of rocket, for lack of a better word, an explosion. But it didn't explode, it was just a sound. So scientists were perplexed, what do we do? And somebody discovered how this bird actually, as it drops into the water to catch its prey, hence the name kingfisher, beak first, it actually, once it hits the surface of the water, it barely basically causes a disturbance on the surface of the water, hence there's no pressure mounting on the beak of this bird. So they translated that into this bullet train, and basically they designed the tip of the bullet train such as the beak of the kingfisher, and therefore when the bullet train exited these tunnels, there wouldn't be any buildup of pressure. Therefore, they went the sonic booms. Excellent example of biomimicry. Another one here, how does nature cycles nutrients? Nature has been cycling nutrients for thousands, if not millions of years in a sustainable way. If we can apply that concept of how nature does it, then we have to assume that we will be successful in being more sustainable during our food production processes. So in order to answer a question or solve a situation, first of course we need to know, we need to identify the problem. Then we can biologize this question, biologize the problem. First of all, we identify functions that are similar, purpose, or role, or use in nature, and then we ask nature, how do you do it? How does nature solve this problem? Now, of course, what we don't want is to do it the way nature doesn't do it. We want to stray away from that, because otherwise it wouldn't be sustainable and so forth. So basically, not necessarily reinventing the wheel, but using something that has already been given to us free and basically innovate something that will benefit us. So integrating life principles, basically the principle of righteousness or being environmentally sound, because if we follow those approaches, that means that we will be environmentally sound. And at the same time, we're environmentally sound, we have to realize that these processes have been going on for thousands of years. Therefore, life has been conducted by these processes. That means that life creates conditions conducive to life. So that means that if we use nature as a model, we cannot go wrong. Also, life adapts and evolves, obviously, and it has been evolving through millennia. And the evolution, in most cases, if life has persisted, is obviously being a positive gain to the life processes, which in turn we can use as a model for anything that we would like to solve using biomimicry. So once we find the process, we evaluate our findings. Our findings are these, in part with our present technology. How much technology do we possess in order to be able to emulate these nature processes? Or we reevaluate if we have to, or we revisit when we're more ready for this. And since biomimicry has been since biomimicry is a way to emulate nature, then we have to assume that since nature is sustainable in its processes, then means that when we innovate from nature, we are innovating for conservation. So the design process has to involve many aspects. It may bring challenges, but it will also bring a very nice vision of what could be. For example, the processes can give us products, physical products. For example, buildings can give us the wing of that we designed from a bird, using a bird as a model for aeroplanes, jet fighters, and so forth. Many products. Also processes. How does water is filtered in nature? We can use that model of reverse osmosis, which we are already using. How does cells take in certain molecules, but not all of them? That means that there's some kind of differential of volume or molecule size that allows some molecules to enter the cell and so forth. So many processes. How do we carry oxygen from one way to the other? We oxidize, but then we have to deoxidize. That's what happens in the surface of the red cell. Also, the implementation of organizations, which allow us for the implementation of these processes, and of course policies. Policies are important, right? Because they allow for the basically for not necessarily pushing, but allowing for the implementation of new technologies that very well could come from nature, for example. So also new ways of living that are well adapted to life on Earth over the long haul. So basically all that's summarized in that paragraph. And of course, biomimicry is our biggest mentor. It encourages biologists, engineers to collaborate using nature as model and measure, which means that it inspires us to solve things. How does nature do it? Can I emulate nature? That is the idea. So life manufactures, does chemistry, builds structures, designs systems, engineers, to within a fine balance. So it means that everything that happens naturally, natural processes, functions, structures that are made in nature, all those are fine-tuned to work. That means that they're almost to perfection to work. So if we want to emulate, we emulate the best, and in this case, obviously, is nature. Always view nature as a mentor. Always view nature as a mentor, meaning that we will find our answers of the problems via nature. We just need to look, investigate, and obviously research. Okay, so this concludes this video lecture. I hope you enjoyed it. I know I got stuck here and there, but either way, just go through it. Okay, there's a couple of videos on the Google Classroom posting, and also a link to the Biomimicry Institute webpage if you want to look at it. I will also be announcing the new project and its parameters within this posting anyway. Okay, so have a great day and stay safe.